NumPy and SciPy are two essential libraries in the Python programming ecosystem, and while both are used for math-type things, there are both fundamental differences and areas of overlap between them. So let's get into what they are, how they can be differentiated, and then some use cases. So NumPy. NumPy is an abbreviation. It's an abbreviation for numerical Python. NumPy, numerical Python. It lets you do stuff with numbers. Now, NumPy works with large multi-dimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. Multi-dimensional arrays, you say? What are those? Well, you can think of multi-dimensional arrays as lists of lists, or even lists of lists of lists. In essence, a one-dimensional array, that's something like this. It's a simple row of items, like a row of numbers. Then you have a two-dimensional array that's like this, and you can think of that as being like a table where you have multiple rows, each of which may contain multiple items. Now this can go even further. We can have three-dimensional array like this, four-dimensional array. You get the idea. Now, consider a real-life application like 3D graphics modeling. You might have a three-dimensional array representing the x, the y, and the z coordinates of each point in a 3D model. Or think about time series data, where one axis represents the chronological order of data. These multi-dimensional arrays are also called tensors, and they're fundamental to a lot of the heavy number crunching required in fields like physics, mathematics, and machine learning. With NumPy, you can perform operations on these arrays as if they were regular numbers, and NumPy handles all the complexity of manipulating these data structures. But that's just scratching the surface of what NumPy is capable of. With the help of NumPy, you can perform mathematical operations, so some basic stuff like addition, subtraction, or you can do things like squaring on an element. You can perform statistical operations like calculating the mean, the median, and the standard deviation of your data. So that's NumPy, numerical Python. SciPy, that stands for scientific Python. And it's not as if it's a competing library to NumPy, which is just as well, given that it clearly has a better name, SciPy. You see, SciPy is actually built on top of NumPy. SciPy leverages NumPy arrays and extends its capabilities. Now, what does this mean in practice? Well, it means that SciPy can do everything that NumPy can do and more. SciPy uses the array data structure from NumPy and enhances it, adding further functionality for more complex mathematical and scientific computing tasks. So it's kind of like a NumPy plus. So in essence, if you're using SciPy, you're also using NumPy. But the focus on SciPy really is on scientific computing, and that means support for routines like numerical integration, interpolation, things like optimization, things like linear algebra, and things related to statistics. And while some functions can only be performed in SciPy, there are overlapping capabilities. So take, for example, interpolation, which involves estimating unknown values that fall between known values. Both NumPy and SciPy have support for this, but there are key differences. So let's illustrate this with a simple example. So suppose we have a set of known data points like we've got here, and we want to estimate the values at new points that fall between the known data, so parts around here. Now with NumPy, we can perform what is called a simple linear interpolation. And that uses the np.interp function. Now this involves fitting a straight line between each pair of known points. So like this, and using this to estimate the unknown values. It's quick, it's efficient, and it's often good enough for simple use cases. SciPy's interpolation capabilities, though, they go far beyond this. So, for example, using SciPy, we can support something called cubic interpolation, or specifically cubic spline interpolation. Now, how this works is a little bit different. It involves fitting a smooth curve through unknown data points, so it would look more like something like this. And this can provide a more accurate estimate of the unknown values, especially when data has a complex nonlinear structure. NumPy's interpolation is straightforward and it's efficient. SciPy's is more flexible and sophisticated. So, where are the libraries typically used? Well, let's say you're working in data science, exploring a large data set to find patterns and insights. With NumPy, you can quickly perform operations like calculating the mean or standard deviation of your data, filtering for specific values, or transforming and reshaping your data. NumPy's capabilities are also well suited to image processing. So let's take a beautifully drawn image like this. Images can be represented as multi-dimensional arrays like this. And here, those multi-dimensional arrays are the dimensions corresponding to, say, height, width, and color channels. And with NumPy, you can manipulate these arrays to apply filters, transformations, and other image processing operations. Now, on the other hand, when your work requires more advanced and specialized mathematical or scientific functionality, that's when SciPy comes into play. Take, for example, the field of signal processing. SciPy has a suite of functions in its signal module for signal processing. So here's a signal. And we can, for example, use its fast Fourier transform functions, or FFT. And what that can do is it can convert the signal from the time domain into the frequency domain. And that will let you analyze the signals for different frequency components. So that might look something like a bar chart format like this. If you're designing an aircraft wing and you need to find the shape that minimizes drag while satisfying constraints like maximum weight and material strength, you could use the optimization routines in SciPy to solve this problem. And look, one key point that underpins the use of both of these libraries is their efficiency. Both NumPy and SciPy are designed to manage computational resources efficiently. And that means they handle large data sets and perform complex operations while minimizing the usage of your computer's memory and processing power. That's one of the reasons why they're a go-to choice for number crunching tasks. In short, if you're working in a field that involves data analysis or scientific computation, chances are you'll be using NumPy, SciPy, or both. If you have any questions, please drop us a line below. And if you want to see more videos like this in the future, please like and subscribe. Thanks for watching.